Students, in the earlier class I have taught the topic of quantization. Today I have discussed the topic. So topic is compounding. At first I will give my introduction. I am Ashish De. Okay. And today I want to teach about compounding. So what is compounding? So what is compounding? Compounding is basically non-uniform quantization, right? In the earlier lecture you have taught about two types of quantization. They are uniform quantization and non-uniform quantization. Non-uniform quantization is practically achieved through the process of compounding. Okay, so it is required to be implemented to improve the signal to noise ratio of weak signal. Okay, the quantization noise, as we know, quantization noise NQ is equal to delta square by 12. What is delta? You know that delta is quantization step, right? Now, from the term compounding, compounding is consisting of two terms basically. Compounding equal to compressing plus expanding. Okay, so these two, the combination of these two terms is basically compounding. Okay, so compounder has the characteristics of both compressor and expander, right? Now what is the compressor characteristics? If you see in two-dimensional figure, if along x-axis there is compressor input and along y-axis compressor output, so the curve of the characteristic curve of compressor looks like this. Okay, there are various points. Okay, so this is compressor characteristics curve. As shown in this figure, the compressor provides a higher gain to the weak signal, okay, and smaller gain to the strong input signal. When the input signal is very strong, then it gives smaller gain because the output as compared to input is very small. Okay, now the weak signals are artificially boosted to improve the signal to quantization noise ratio. It may be noted that this compressor characteristics has been shown only for the positive input signal, but we can draw it even for the negative input signal using some principle, right? Now you have to see what is expander characteristics. The expander characteristics will looks like this. Okay, here is the expander output, and along x-axis there is expander input. Okay, so expander characteristics looks like this. Okay, now Compounder characteristics. Compounder characteristics basically consisting of compressor characteristics and expander characteristics, right? Now it will looks like this. If I draw here, then it will looks, if the linear characteristics is this, okay, along x-axis there is input voltage, of compounder, and along y-axis there is output voltage of compounder. Okay, then in the positive side there is a compressor characteristics like this. Okay, and for negative side the compressor characteristics look like this. Okay, in vice versa, the expander characteristics look like this way. Along in first quadrant or positive x-axis, and in the negative x-axis, along negative x-axis the expander characteristics is this. Okay, so this is basically compression. Here is also compression, and these are basically expansion. This is also expansion. As you see from here, in the when there is for positive x-axis, the compressor characteristics will look like this, but the expander characteristics will look in the downward direction. Okay, so here is also the compressor characteristics is this and expander characteristics is this, but when the value of x-axis is negative, then the expander characteristics is here and compressor characteristics will be here. Okay, this is basically compounder characteristics, which consisting of basically compressor characteristics and expander characteristics, right? Now, inverse nature of compressor and expander, the overall characteristics of the compounder is a straight line. Okay, that is shown by this dotted line. Okay, this indicates that all the boosted signals are brought back to their original amplitudes. Okay, so this is basically this is for ideal case. Okay, so in ideal case we can get this kind of characteristics. Okay, now compounding model consisting of basically a compressor. So it consisting of a compressor, okay, a uniform quantizer, again an expander. So there are three portion of a compounder. Okay, so this is the input section and here is the output, right? So it is basically consisting of a compressor and expander. Okay, so it is difficult to implement the non-uniform quantization because it is not known in advance about the changes in the signal level. Therefore, a particular method is used. The weak signals are amplified and strong signals are attenuated. before applying them to a uniform quantizer. Okay, this process is called as compression, and the block that provides it is called as a compressor. At the receiver, exactly opposite is followed, which is circuit used for providing expansion is called an expander. The compression of signal at the transmitter and expansion at the receiver is combined to be called companding, right? So that is companding. So from here we can say that compressor is used in the transmitter section of compounding and expander is used in the receiver section of compounding.